All right. Okay, so suppose it says, find the distance from this point right here, 7, -3, 4, to, and then part A, I just said the YZ plane, and then B, the Z axis. Yep. Okay, so this is similar, just to a different axis. Okay, so think about how we would plot this point, right? So I'm not going to do it perfectly. So say this is X. Hey, Austin. Y, Z. This is the first problem we're looking at. And I just made one up. Oh, I thought I asked a question like this. Okay, so find the distance from a particular point to the, so first part I said YZ plane, B, Z axis. So the point is 7, -3, 4, which means we should come forward 7. -3, so that means we should go left 3. So I want this line, let me get my straight edge here. So here I'm at 7, so I want to go parallel to the Y. And then I want to go 1, 2, 3, and then see where those meet. And then up 4 from that spot. So go straight up 4 units. So I'm just going to go from this point in the floor. Okay, so 1, 2, 3, 4. Okay, so there is that point. And we want to figure out how far it is from the YZ plane. So think about the room. Which part of the room is the YZ plane? Is it the side wall? Is it the floor? Is it the back wall? Yes, because Z, it has to go up and down. So it can't be the floor, it's one of the walls. And the Y goes left to right, so that would be the back wall. So we want to know how far away that point is from the back wall. So how far would we have to travel to get back to the back wall?
From up there?
From this point right here. And you just go anywhere on the back wall. Four, right? Because no, not 4.
Wait.
You talk about YZ plane, which is the other
right.
side.
Well, it's the whole YZ plane. It's right. The whole, right.
There.
You mean to go there.
Right, how do... Well,
you mean to reach the core, like to the edge of YZ plane?
Any part of the YZ plane.
If you go -7, X -7.
That's it, right, because we came, right, so it's 7 units, because here the first thing we did was we came forward 7 units, so to get to the back wall, we just have to go back 7 units.
Yeah, which is like negative.
Right,
7.
so the distance to the YZ plane would be 7 units. Yep, and you can just say 7 units. Okay, now, and that one I think is a little bit easier to visualize going back to a wall than it is to an axis, right? Although there are infinitely many points you could go back to get to the wall. It's like, well, it's best if you just go straight back, right? Yeah. So straight back 7 units. Whereas the Z, I'm going to have to go back and I'm going to have to go to the right. Right? So it's like, okay, it's maybe a little bit harder to visualize. But let's think about if a point is on the Z axis. So if it's somewhere on the Z axis, what's the X coordinate of that point? Right, X and Y are both 0. The Z, yeah,
we'll pick 4 when you get
yes.
going straight back.
Yep. So, and this was the question she had, like, how did you know that? So for now, I know that if I'm on the z-axis, x and y have to be 0. The key is, what's the best z to choose? Well, let's use the distance formula with these 2 points. Okay, so distance is square root, right, x2 minus x1 squared. So I'd have 7 minus 0 squared, plus y2 minus y1, so it'd be negative 3 squared, and then plus 4 minus z squared. There's nothing I can do to change these, right? Those are fixed. What I want to do is make this one as small as possible, right?
Yeah.
What's the smallest this could be?
The 4 minus z squared.
Right, what's the smallest that could be?
Would be 4.
You choose 4, right? The smallest it could be is 0, right?
Yeah.
Since it's something squared, it could never go negative.
Right.
So the smallest possible value is 0, and that happens when z equals 4. And so when z equals 4, that part's gone, and so the distance would just be the square root of 49 plus 9, so it'd be the square root of 58. So that's the distance from this point to the z-axis. We choose the z to be the same x
So when
and
you're
y.
looking for the axis, this is you using that distance formula.
Right, so if I said find the distance to the y-axis, well, then you know that x and z are 0, and what would you choose for the y? Negative 3.
Negative 3. Yeah.
Right, yep.
Yeah.
Okay.
Yeah.
All right. And Austin, I just said, I'm answering any question.
Okay, negative 3 minus 3, so it'd be
Yeah.
plus 3,
Yep.
negative 6 plus 6.
Minus negative, yep.
Yeah.
And it can be from any of the test reviews, it can be from WebAssign, it can be group work, it can be anything. But I don't have anything planned, I'm just answering questions. And I have the test reviews up. The one thing, I think you might have walked in after I said this, I'm not sure. On the content page of D2L, I have several Test1 things posted. So the Test1 review questions and formulas that you should look at, that's the second page of that, or the third page, I'm sorry, is what will be the cover sheet of the exam. So here are all the formulas that will be on the cover sheet. And then the second document, that just has the answers to all of the problems in that. And then video from a previous semester. This Test1 review more problems, this thing right here, that is just one semester somebody asked me, can you give us more problems to study? And I was like, okay, sure. But it's not something that I expect you to do. I mean, trust me, there should be enough there already, because I also suggest that you study group work. But there is just, if you find yourself like, oh, I've done everything, I want more problems, it's there. But then I did realize that this document right here didn't have a ton of stuff about like forces and vectors. So I did add this document, Test1 vector problems, and it only has 3 questions on it, but just a little bit of practice, more practice with vectors.
Question.
Yeah.
Okay, for the projection and the components,
Yep.
what's the best way to like if it says projection B onto A?
Okay.
So how is that? Because on I wrote like the formula, but
Yeah.
to correctly translate it.
Yeah.
Like if it's B onto A, which mean like can it mean like some?
Yep. Hang on.
Better
Yep.
understand it.
Yep. Okay. So this is one of the formulas I'm not giving you, right? So first, and you said you wrote down the formula, but I'm going to give you something that will maybe help you memorize, but I want you to understand also like where that formula is coming from. So I'll talk about that.
So if it's a B onto A, so then it's going to be B times A or A times B onto a translated.
Dot product, it doesn't matter what order you do.
But the bottom.
Right, the bottom is always, you use the same vector twice. So you would never have B and A in the bottom. You're either only going to have A or B. And it's whatever one is going onto. So whichever one you're projecting onto, that goes in the bottom. So like here, you write it this way, notice A is already kind of lower. It goes right in the bottom, A dot A. The numerator is you dot both of them. So A dot B. The vector, hang on, the vector you multiply by is the one you're projecting onto. So what vector goes at the end? The one you're projecting onto. So notice the one you're projecting onto gets used 4 times basically. The one you're projecting only gets used once, right?
The component is
just like,
cross product.
nope. The component has the same numerator. So the component of B along A is still A dot B or B dot A in the numerator, but in the denominator it's just length of A.
Yeah. And if it's a component
of A on B,
onto B, then
it's B in the denominator.
So they pretty much, whatever you're onto,
yes,
letter, that's going to be
right.
Once, right?
Right. So like if I was doing, I'm just going to use 2 totally new letters. So if I was finding the component of W onto V, then in the numerator you dot them, and it doesn't matter what order you do, because dot product, it doesn't matter, but then the bottom is V. Right. And if it was the projection of W onto V,
so the lower letter will be on the bottom.
Yes. Right.
The top one doesn't matter.
Right.
Oh, okay.
V dot W or W dot V.
But see, on the projection, see, you're multiplying also to the A, to that vector?
Yes.
That's that same vector, wherever it's used.
That you're projecting onto. Yes.
So your projection will always be a vector component scalar.
Yes. Yes. Very important.
What did you say?
The projection, your answer is a vector.
Scalars for the answer.
Yep. Your component should be one number. The projection should be a vector. So without, like, say I didn't even know what I don't give you numbers. Like, I just give you a picture. Like, this is A, this is B. I'll do a couple different pictures. And suppose, I'll do 3 different pictures. Suppose I do, I want to do this. The projection of B onto A is like, you think of A is the ground, right? What you're projecting onto. And then think of the sun being directly overhead, right? So where A is the ground, right? So the projection is like B's shadow on A. So in the first picture, I would think, okay, well, if the sun was directly overhead, its shadow is gonna, oops, this is dead. The shadow is gonna come straight. There's the sun shining, right? And then here, this part is the shadow. That vector right there, this is the projection of B onto A. The component is the length of the shadow. Okay? The projection is the whole shadow. It's a vector. The component is the length. So what about this picture right here? It's fine that B is longer. What you would do is, if you need to, you just extend A. Okay. And then you think, okay, well, what's B's shadow going to be like then? Well, okay, the sun is directly overhead. It's going to come down and hit right there. And so now this whole thing is the projection of B onto A. Sorry. And then the component would be the length of that shadow. Okay, what about this third picture? Where you think, okay, well, B's not even going to hit A because it's going in the wrong direction. Then you just extend A in the opposite direction. But then you do the same thing, like where is the sun, where's the shadow going to be? Right. Now the sun's going to come down and hit right there. And so this time, there it is. So this right here is the projection of B onto A. The component, still like the absolute value of the component is the length. This time the length, the component is going to be, hey Tim, is going to be a negative number since the projection goes in the opposite way of A. But say you get like -4. The negative means it goes in the opposite direction of A, and then 4 would be the length of the shadow. Okay. Does that help?
So the component of B onto A
Yep.
is the green, and then what we do?
No, well, this right here, that's the projection. The projection is the whole vector. The component is just the length.
Oh.
So it's however long the green vector is. It's not the green vector. The component should be one number.
Is this the length?
Yes. Right. But it might be, you might get a negative number, like in this picture right here. When you do the component, you're going to get a negative number because the shadow goes in the opposite direction.
Yeah.
But say you got -4 as you did the component and you got -4. That means the length of the shadow is 4, and the negative means it goes in the opposite direction of A. Yep. What else?
You go through number 2 on the 13 page report.
Yes. Let me write it down. Okay. And that was unit tangent. Okay. Okay, so if I ever ask you to find the unit tangent vector, this is what you should do. So first, just find a tangent vector. So we just want something that's tangent. Then after you do that, turn it into a unit vector. Okay, so if we're given the vector function, what do we do to get its tangent? Derivative, right? So just the regular tangent is given by r prime. And we'll do just component by component. So for the first component, the 6 is a constant that stays out in front, and then the derivative of sine 2t would be
2 cosine.
2 cosine 2t, right, from the chain rule. Yep. So the 6 times the 2 would give us the 12 cosine 2t. And then similarly for the second component, it's just the derivative of cosine is negative. So we'd get negative 12 sine 2t. And then the third component, just 5. Okay, so that is a tangent vector. It's probably not, well, it's definitely not a unit tangent vector because the last component is 5, so it's at least 5 units long, right? So now we want to make this a unit vector. How do we make something a unit vector? What do we need to do first? Right. So find its magnitude, which is the sum of the square root of the sum of the squares of its components. So magnitude r prime, square root, we get 12 cosine 2t squared plus negative 12 sine 2t squared plus 5 squared.
Then did I miss the beginning of that? Because how did we get 12 again?
Well,
6?
because the chain rule, the derivative of sine 2t, the inside function, you have to multiply by 2.
Yeah.
Yep. Okay, so 12 squared is 144. 144 sine squared plus 5 squared is 25. Okay, well, they don't all have something in common, but the first two terms have something in common. What do they have in common? 144. If I factor that out, I'd be left with cosine squared 2t plus sine squared 2t, but that's just going to be what? 1, right? So this whole thing is 1. So I just have the square root of 144 plus 25. So square root of 169, which is just 13. Okay. And then, so now here's the tangent vector. Here's a tangent vector. Here's its length. So the unit vector would just be 1 over the magnitude times it. So t is 1 over 13 times r prime, which is 12 cosine 2t negative 12 sine 2t 5. And then you can distribute the 1 over 13 through.
On the test, which form do you prefer?
I would accept either. Yep, I know.
But for the question was find the length in the portion of the curve.
No, he asked a question about number 2.
Oh, it's just for the 2.
Right?
Mm-hmm.
Yeah. Right. So if we were looking at number 1,
It is, should be like.
Then you, right, so that was for number 2. For number 1, it said find the length where t goes from where to where, 0 to pi. So the formula, and that I think is on the formula sheet. Yeah, right there. Right? That's you need to know that that's the arc length formula. And then remember, x is the first component of the vector, y is the second, z is the third. So we just did the square root of the sum of the squares of its components and got 13.
Right.
13.
Yep.
So what that formula would have reduced to is the integral from 0 to pi of 13 dt. Right?
Mm-hmm.
And then when you integrate 13, you just get 13t going from 0 to pi. So you get 13 times pi minus 13 times 0. Right. So the answer is just 13 pi.
But what's the name of the formula you just said?
The arc length formula. Get a little preview of stuff we'll be doing later in the semester. Doing work in vector fields.
I thought I heard you say something about tangents and the formula. Something about our tangents. I was saying something about tangents. The one that had like the derivatives and stuff. No?
Oh, for number 2?
Yeah.
Yeah.
Not this formula, but
This one?
that one. That's just the arc length formula.
That's the arc length formula.
That's it. Okay.
The integrand is the magnitude of the tangent, not the unit tangent, the magnitude of r prime,
Okay.
right?
Yeah.
Mm-hmm. Okay. What else?
Problems showing how to find curvature.
Yeah. Let's see if there's one on here. So let's look at 20. So this is from the test review. So this is number 21 from the test review. I'll write it down and then switch over to the projector. And then I'm gonna go to the formula sheet, and we have a couple different formulas for curvature. There's one. I'll go ahead and write that one down. This one, oops. Well, but this one, we're never going to use that. That's only when y is a function of x. We don't have that. So we're using, ours are pretty much all parametric.
What is that formula for?
Also curvature.
Okay.
Curvature is given by that kappa, Greek letter kappa. Okay. So I have these two formulas as options. One thing I notice about both of those formulas is they have r prime in them. So regardless of which way I decide to go, I have to find r prime, right? So I'll at least start there. So r prime, what's its first component? Square root 3. What's its second component? E to the t, and third? negative e to the negative t. Okay, they tell us the point where we should do it, but this is x, y, z. I need to know what t is, right? So if this is the point, what's t? 0, right? And you can just look at the first component. The x has to equal 0. Well, the only way square root of 3 times t is equal to 0 is if t is equal to 0, right? So we're doing this all at t equals 0.
The R prime is just
Of each component. Yep. So I'm going to do r prime of 0. So what's the first component? Square root of 3. It's just constant, right? Square root of 3. And then what's the second? 1. And then negative 1. And again, in each of these formulas, I do have to find the magnitude of r prime. So I'll just go ahead and do that right now. Magnitude of r prime at 0 is square root. So square root of 3 squared would just be 3, right? Plus 1 plus 1. So square root of 5. Okay, so now we have the choice of either, well, finding t prime. We haven't even found t yet, right? And t is r prime divided by its magnitude, right? Because r prime gives the general tangent vector. To make it a unit vector, we divide by its length, right? But here's the problem, is I can't use this, right? I have to use the one where it still has the t in it. So if I found the magnitude of this, I'd still have, well, when I square this, I'd get e to the 2t, and when I square that, I'd get e to the negative 2t, so I'd have the square root of 3 plus e to the 2t plus e to the negative 2t. No? Right, yeah, and right, because I still have to take the derivative of that, right? So, because, right, the formula has t prime in it. So not just t, so yeah. Then I ask myself, okay, I don't think I want to go that route. Then I ask myself, well, is it hard to find r prime? No, it's pretty easy to find r prime. So this is definitely going to be the way to go.
It seems to me that most of the examples you've done in class, that's the way we've gone.
When it wouldn't be the way to go is, like, say we had, one of the terms was like x log x or x cosine x or something, where every time you take a derivative, you're using the product rule, so it's just going to get longer and longer. Mm-hmm. So then I would probably do this, because I don't really want to take two derivatives. But yeah, if it's not too bad to take derivatives, I would say this is the easier way to go. Yeah. Okay, so r double prime. So what's its first component? 0. Yep. And then the middle component, e to the t, and then the third component, e to the negative t. And then we'll evaluate this at 0. So it'll be what?
0, 1, 1.
0, 1, 1. Okay, and then for this curvature formula, now we have to do the cross product. So here's, we can do the cross product after we plugged in, but we can't do derivative after we plug in, because then we'd always get 0, right? So r prime cross r double prime. Oops. Okay, so square root of 3, negative 1, 0, 1, 1.
So I'm confused. So first, going back to where you have the red star,
Mm-hmm.
from there we took the derivative, and that's how we got the prime 0. No, prime 2.
Oh, we plugged in t equals 0
Uh-huh.
because they said it's at this point.
Mhm.
So I want to know, okay, well, if this is the point, this is x, y, z. That's not t, right? I have to figure out what t is.
Okay.
Well, when does x equal 0? And remember, the first component gives x.
Oh, yeah.
So if this is equal to 0, it must be the case that t equals 0.
Okay.
Right? Also, where does e to the t equal 1? Only at t equals 0.
Oh, yeah.
Right?
Okay.
Yep.
So the first word from the star, you wrote the derivative from that star. Then you found the no.
Well, I plugged
And you
in
plugged in
0,
0.
and then I found the magnitude.
Yeah, you plugged in 0. Yep, that's how you
And then when I said, okay, we're using this formula for curvature,
Mhm.
there's an r prime, but we also need our double prime.
Yeah.
Okay, so then I had to go back to where I have the star
Yeah.
and take the derivative to get our double prime.
Okay.
And then, just like before, plug in 0.
Oh, you took the derivative and then plugged in 0.
Yeah,
That's what the R prime is.
our double prime.
Oh, okay. Because how come when you took the derivative, it wasn't 0 for the first one, but now it's 0?
Well, the derivative of square root of 3, that's a constant, right? So its derivative is 0,
The second,
right? It's our double prime. We're taking the derivative of the derivative. So the derivative of a constant is 0, and then the derivative of e to the t is e to the t. And then here when we take the derivative, we're going to get another negative, which makes that positive. And then e to the negative t.
That's the first one plus t in there, so first derivative we just square it to the 3, and then it's another derivative is 0, so it's pretty much.
Yeah, right. So what he said, like the square root of 3 is a constant that stays on in front. The derivative of t is 1. So square root of 3 times 1. Now there's no t there anymore, so it's just a constant.
I'm so confused.
So there's a
How come it's 0?
Yeah, okay.
Thank you.
Yes.
Yeah.
Okay, so the I is times 1 minus negative 1. So that would be 1 plus 1 minus j times square root of 3 minus 0 plus k times square root of 3 minus 0. So we get 2 negative root 3 root 3. And now for curvature, I need to find the magnitude of that. So I get the square root of 4 plus 3 plus 3. So square root of 10. And so the curvature is that, square root of 10, over the magnitude of r prime cubed. And the magnitude of r prime was root 5. I need to cube that. So I get square root of 10 over 5 root 5. And then 5, this 5 goes into that 10 twice. So I just end up with the square root of 2 over 5.
What are you doing? You simplify it, what did you do there again?
Okay, so think of
No,
the last one.
No, that's.
From here to here?
Yeah.
Okay, so these are both under the square root, right? You can think of the square root of 10 as the square root of 5 times the square root of 2,
Oh.
right?
Okay.
And just cancel a square root of 5.
Good.
Yep. And then I'm just going to make sure that that's what I have on the answer sheet. So
All right.
this was number 21. Yeah, square root of 2 over 5. Oh,
back there.
Good advice. Somebody just joined the meeting.
now?
Yep.
Maybe.
Okay. Oh, he left.
Your science is too slow. Trouble showing on my screen all these delays. Probably just decided it's tough.
I don't even think he was on long enough to, he probably just heard me say, oh, somebody joined. Never mind. Okay.
Going back to that problem.
Mm-hmm.
Okay, you have to, you cross, so you're crossing the prime with a double prime.
Mm-hmm.
And then you see that one of them, okay, the bottom part is the, I'm guessing that's the double prime?
Yeah, our prime goes here, our double prime goes there.
Can I see our prime again? Oh, that's the one, okay.
Mm-hmm.
We'll try number 20. Or the 125 or 26.
Okay.
Are they the same or kind of?
Well, one of them says find tangential and the other one says find normal, but
Let's do tangential.
okay. So let's see. Actually,
Hey, Kristen, you're gonna be available online.
yeah.
Before we start this,
Mhm.
just looking at number 7 and just telling me if I'm correct, the formula for that is just FD cosine theta. I think I'm right.
Yeah.
Okay. Oh, no,
Mhm.
Number 7, what did you say the formula is?
FD cosine theta.
In that particular one.
Yeah, and so
It
yeah.
helps when I do the formula, I learning to place them with the problems and if I hopefully I don't.
It's right here. It's on the formula sheet. Magnitude of F.
I mean, you could F
Or the
cosine
Yep.
theta D like that.
But yeah, like if you in a right, it's just because it's multiplying, right? So you can multiply any order you want.
Okay.
So magnitude of the force, cosine of the angle between them, D is the displacement. And so yeah, 7 is, yep, the magnitude of the force is 28 pounds, a ramp that's 3 feet long, so there's your displacement, and 13 degrees is your theta. Yep, so it's just plugging everything in. There. Okay, 25.
Oh, yeah.
For both of these, why don't we just look at 25 and 26 and we'll find both tangential and normal components for both of them. Okay, so I have these formulas for finding tangential and normal components of acceleration. Yep, but I mean, you don't have to use all three. You get to decide which ones you want to use. So the first equation says AT equals V prime.
And this tangential and normal is the same as like when you were asked to find T and B.
Yes. Well, Tn and B are vectors. At and An are scalars. Yeah. So from that first equation, we can see just equating the coefficients of T, that A sub T equals V prime, and A sub N equals kappa v squared, or we can use these other formulas. AT equals R prime dot R double prime over magnitude R prime. AN equals R prime cross R double prime. Yeah, these are on the formula sheet.
I don't realize it.
Okay. Get refocus. Come on. You can do it. Maybe not. There we go. Okay. So, regardless of which formula which set of formulas we use, for these, they both involve a v, that's a scalar. These two both involve both r prime and r double prime. But r prime really is what? What does r prime give us?
Vector, doesn't it?
Right, what vector?
Your tangent vector.
And we have
A tangent vector.
a tangent vector. And if we're talking about r as the position function, what does r prime give us? The derivative of position, velocity, right? This v is speed, right? V without the arrow is speed, which is the magnitude of velocity, but velocity is r prime, right? So regardless of which formula we use, we at the very least have to find r prime, right? So what is r primes? And this one, it started out in IJ notation. I just put it in bracket notation because it's quicker. So that's why it only has two components, just IJ. So this is a two-dimensional problem. So what is it for r prime? What's the first component? Mm-hmm. And then the second?
24T.
24T. I don't think I said add a point. I think I just said find it. Okay. Okay. That is also velocity. So regardless, again, of which set of formulas I use, I do have to find the magnitude of that. Okay. So magnitude of r prime is the same as the magnitude of v, which is the same as speed, is the square root of 12 minus 12t squared quantity squared plus 24t whole thing squared. Okay, so think about doing FOIL. So 12 squared, 144. Outside would give me minus 144t squared. Inside would give me minus 144t squared. So minus 144 minus 144 minus 288 t squared plus 144t to the fourth. 24 squared is 576. So I can combine these two terms, and 288 is half of 576. So you just get 144 plus 288 squared plus 144 t to the fourth. I can make this look nicer, right? Because this is almost exactly like those three terms, right? Just with a plus instead of a minus. How did I get these three terms? By squaring this, right? So these three terms would be 12 plus 12t squared quantity squared, right? If I did FOIL with this, I would get these three terms. And so the square root and the square cancel each other out. And so we just get 12 plus 12t squared. Notice that's V. It's pretty easy. If this is V, pretty easy to find V prime, right? So I'm just going to use this first formula for AT. So what would AT be?
Oh, 24T.
24T, right? This is V. All I'm doing is taking the derivative. 0 plus 24T. If you used this formula, you would end up at the same spot, but you would have to find our double prime. Let's just check.
So which one are you using? The left one or?
Well, it's tangential.
Oh,
yeah.
Okay.
Yeah.
So it's,
Right. So if we found our double prime, what would we get?
Negative 24T, 24.
Yep, negative 24T, comma, 24, right? Because here's our prime. I'm just taking the derivative of that. And so if I did R prime dotted with R double prime, okay, first times first, negative 24 times 12. Okay, so 24 times 10 would be 240. 2 more would be 48, so 288. Negative 288t, negative times negative is positive. 288t times t squared is t cubed. And then second times second would be 576t. When we add those two together, we get plus 288t. And then I would have to divide by the magnitude of R prime, which is right here. So I'd have AT equals this. I'm going to factor out a 288t. 288t, and then I'd be left with 1 plus t squared. Divide by this, so I'll factor out a 12 and be left with 1 plus t squared. So the 1 plus t squareds cancel. 12 into 288, well 12 goes into 28 2 times with a 4 left over. 12 goes into 48 4 times with nothing left over. And then the t, right? So you get the same thing either way, but this particular problem, it was a lot easier to just use the first formula, do V prime.
so the first one, the AT is pretty much R prime? AT or V prime, right? AT.
It's the derivative of speed. Yes.
So the first formula then is what you're saying.
Is it always
You use
that or is it not?
I just
always
used
that?
both of them.
Both of them.
I just showed that regardless of how you do it, you get the same answer. So first, I used the first formula. I said, regardless of which formula we use, we at least need to find R prime and then its magnitude, because that is V. Magnitude of R prime is V without the vector. It's speed, right?
And because that's the prime.
Right.
And that's pretty much a cut.
And if speed is not complicated, then just go ahead and take its derivative. And here speed was not complicated. So I just said, okay, let's just take the derivative. There's the tangential component. If it was,
When is it complicated?
well, say you had like x, e to the x, arc tan x, right? So you're going to have to use, you know, like product rule a bunch of times. You know, you could have a really complicated function. Then I wouldn't want to take the derivative of that. But this one, it was easy. So I just took the derivative. But I said, if you had your heart set on using this formula, you'd end up at the same answer. Yeah, I don't want you to use both of them on the test. Just pick one. Okay, now suppose I had asked us to find also, this problem I did only ask you to find the tangential component of acceleration, but suppose I asked you to find both. For the normal component of acceleration, well, then I have to find curvature, which we saw earlier. We had those two formulas for curvature. We've already found the magnitude of r prime. I don't know that I want to do t prime. I mean, you could, but you'd have to do r prime divided by its length, which was this. So you would have to use the quotient rule here. You'd have 24t over this. So you'd have to use the quotient rule. And I don't want to do that. So since I don't want to find curvature, I would say, okay, I'm going to use this formula to get the normal component of acceleration. We've already found what we need for the derivative, for the denominator. We found this. So r double prime. Here is r prime. How hard is it to take the derivative? Not hard, right? So r double prime, what's its first component?
We found our double prime.
Oh yeah, we did, it's right here, right? Negative 24t, 24. Okay, 8 sub n says do magnitude of r prime cross r double prime divided by magnitude of r prime. Okay, I already know the magnitude of r prime is 12 plus 12t squared. We did that up here. I'm going to just give us a reminder of what r prime is. So I don't have to keep sliding the paper up. Okay. Cross product is set up for 3-dimensional vectors. We only have 2-dimensional vectors. How can we make it work? 0 in the third component, right? So r prime cross r double prime. So r prime, 12 minus 12t squared, 24t 0. And then our double prime, negative 24t 24 0. Okay, so I is times 0 minus 0. J, 0 minus 0. Plus K. Okay, this times this. So 24 times 12 we know is 288 minus 288t squared minus negative, so that's going to be plus 576t squared. So those last two terms you can combine, and we get 0, 0, 288 plus 288 t squared. And so the magnitude of that would be the square root of 0 squared plus 0 squared plus this squared, right? So the square root of this whole thing squared, the square root and the square cancel each other out, and you just get that. So 288 plus 288t squared. In the denominator, you can factor out a 12. In the numerator, you can factor out a 288. The 1 plus t squareds cancel, and you just get 24. So your normal component of acceleration is always the same. The tangential component wasn't. It was changing. It depends on time. So at the beginning, like if t is close to 0, a sub t is really small. So you're hardly changing your speed. So you have almost a constant speed at the beginning. The a sub t is like how we think of acceleration, like step on the gas, let up on the gas. That's your a sub t, how you're changing your speed. So if t is small, this isn't, your speed is hardly changing. But as time goes on, wow, you're really stepping on the gas. You're going faster and faster. The a sub n is always the same, means, well, your curvature is going to be changing. Except if they were both, well, sort of, except for it's getting less curvy as time goes on. Because if you were going faster and the curvature was the same, then you would be pulled more, right? Yeah. Yeah. If this was 0, like just it was always 0 and this was 24, then you're going in, yeah, like a helix, perfect circle. But the fact that your a sub t is changing, if your speed is changing, but this is, yes, yep.
Is that just a coincidence that a sub n is a derivative of a sub t? Or is that something that would happen in 2-dimensional space but not 3-dimensional?
I think it is a coincidence here. If it's not, then it is only true for 2-dimensional space. Because, yeah, for 2-dimensional space, you're always going to get 0, 0. So it's always just going to be the absolute value of your third component. Always, always. Mm-hmm. The magnitude of the cross product. And I do still think it is a coincidence, because if they were, what if they were perpendicular? Then the dot product would be 0. So if you were going around just in a circle, R prime dot R double prime is always going to be 0. And then, but R prime cross R double prime, if you're going around in a circle, you definitely have a normal component of acceleration. So you would get 0 for AT, but you would get a different constant for AN. So obviously it wouldn't be the derivative of 0. Yeah. So that was a coincidence for this problem. Okay. Do you want to also look at 26, or do you want to do a different problem? So 26 is the same idea, it's just a 3-dimensional problem instead. But notice the third component there, R prime is just going to be 8, and then R double prime, the third component, would be 0. So I'd probably still use the same method, the dot product and cross product, as opposed to the other formulas. So it's really going to be very similar to what we just did.
Go through how to find T and V.
Yeah. So let's see if there's one on here. Although 20, I only ask you to find t. Let's just go ahead and do t, n, and b. And I don't ask for it at a particular point. Okay, let me refocus if it doesn't. I thought it was gonna, there we go. Okay, so the first thing we want to remember is t, that means the unit tangent vector. So the first thing you want to do is just find a tangent vector, then worry about making it a unit vector. Right, exactly. But we didn't go on and find n and b, right? So the first thing we want to do is find a tangent vector, and what always gives us a tangent vector? R prime. Okay, so what's R prime's first component? 8t. Except for there's a 4 in front, yep, so 4 over t. Okay, that's definitely not a unit vector because there's an 8 in the second component. So we need to find, how do we make it a unit vector? What do we do? Find its magnitude and then multiply by 1 over. So the magnitude of R prime is, when I square 8t, I get 64t squared. And when I square 8, I get 64. And when I square 4 over t, I get 16 over t squared. Okay, well, one thing I notice is that for sure 16 goes into everything. That'll make things a little nicer. Okay, I'll just do that to start. So I'd have 4t squared plus 4 plus 1 over t squared. So I'll bring a 4 out in front. Okay, I don't like having fractions that, like here, is going to make things really hard in the next step if I leave that here, the 1 over t squared. So think about, what if I factor out 1 over t squared? Well, I know the last term then is going to just be plus 1, right? What about the first 2 terms? Well, I'm not affecting the number, right? So the 4 would just stay there. Well, no, because if I distribute back through, I'd get 4 over t squared, and I want it to be 4 times t squared. So what would have to go here so that if I multiply back through, I get 4t squared? T to the 4th. Plus, and then the middle one, the 4 stays, but think of, if I distribute, right, 4t squared, because here the t squareds would cancel if I distribute back through and I just end up with that 4. And the square root of 1 over t squared would just be 1 over t, so I'm actually going to bring that out in front of the radical too, so I'd get 4 over t. Now let's focus on this part. Think about factoring that. Well, everything's positive, so it would have to be plus plus. The only way to factor 1 is 1 times 1. What could I start each set with? 2.
We'd have 2t squared.
2t squared. Right? So this is really 2t squared plus 1 quantity squared. So then the square root and the square cancel each other out. So I get 4 over t times 2t squared plus 1, which I'm just going to write as 4 times 2t squared plus 1 all over t. If this problem, if all I did, which is actually what I only asked you to find t, I wouldn't worry so much about this simplification, but if I had asked you to also find n and b, you want to simplify as much as you possibly can before going on to trying to find n, because n involves taking derivatives of t, so you want to make t look as simple as you can before you try to take a derivative, right? You wouldn't want to leave it like this and take a derivative. Think how horrible it would be to take the derivative of that. 1/2 this to the negative 1/2 times 8t minus 2t to the negative 3. It would just get really, really ugly.
Well, yeah, I would just bring it so it's not bring t squared to the top.
Well, you'd still have to call it t to the negative 2, and then the derivative is still negative 2 to the negative 3, negative 2t to the negative 3. It's still going to be ugly, yeah. So here, we don't have a square root anywhere, so we don't even have to use chain rule, right? At least here. Okay, so now t is 1 over r prime. So 1 over this fraction is just the reciprocal, right? So we just get t over, I think I'll just go ahead and distribute the 4. So 8t squared plus 4 times r prime, which is 8t, 4 over t. And if you want, you can distribute through. This is our answer for t, or you can distribute through. The only one that really simplifies nicely is the third component, because you can cancel a t, but you can't really cancel.
So you accept that.
Oh yeah, this is fine. So now n, how to get n, you kind of have to, this is something you need to remember. N is the principal unit, right, t prime divided by its magnitude, yeah. It matches t, so what with t, you go to the starting, you take the derivative of what you started with, divide by its magnitude. Now you go to the previous vector, take its derivative, divide by its magnitude. Yeah, so it's kind of the same pattern.
It's like pretty much like a position.
Yeah.
Pretty much.
Right.
Okay.
Yep.
All right.
Okay, so t prime. So I think what I would do to find t prime is I'm going to first think of t as like, there's a scalar function out in front times this vector. And so when I want to take the derivative, I need to use the product rule. So I think of it as first times the derivative of the second plus the second times the derivative of the first. Okay. Okay, so f of t stays the same, so t over 8t squared plus 4, and then the derivative of this. So now the first component, yes, yep. So we just get what? That's antiderivative. Yep, so you think of it, 4t to the negative 1, so negative 4t to the negative 2. Or negative 4 over t squared. Plus, okay, f prime, we are going to have to use the quotient rule here. Okay, this is way more difficult than anything I would put on the test, right? Because I didn't ask you to do this on the test review, but I just said, let's just practice, okay? So I wouldn't put anything this hard on the test, but it's good practice, right? Okay, so taking the derivative of this, so it's the bottom times the derivative of the top, which is just 1, minus the top times the derivative of the bottom, which is 16t, all over the denominator squared.
Which is the factor, I mean, the bottom first. If it's square, then they're gonna be.
Well, you could FOIL if you want, yeah, 64t to the 4th plus 32, 64t squared plus 16. And then, so that's f prime times w. See, on the test, I had a problem like this where I asked you to find Tn and B. It would probably be at a point instead of like just find Tn and B, not plugging in any values of T, because this, like say I wanted you to evaluate it at T equals, I couldn't do 0 because it would be undefined at 0, but right. Exactly. So then like say T equals 1, right? Then it wouldn't be too bad. Because there's no way I'd have you find, even when we simplify, that I would have you find the magnitude of this, right? Because you're still going to have to square the components, add them together, take the square root. So maybe we'll look at what if I asked you to do it at a particular value of the parameter. Okay, so this one, if I distribute through, I get 8t over 8t squared plus 4, 0. And then this t would cancel one of those t's. So I'd have negative 4 over 1t left in the bottom, 8t squared plus 4. And then in the numerator, if I simplified, I have minus 16t squared here at the end. So I'd have 8t squared minus 16t squared, which would be negative 8t squared plus 4. And then I'm just going to leave this 8t, 8, 4 over t. So let's say I had done at t equals 1, at little t equals 1. So then t prime would be 8 over 12. I just made it up. Yeah, because this is really, really hard to simplify, and then we're supposed to take the magnitude. That's going to be horrible, right? I wouldn't have you do that. But if it was all numbers, I expect you to be able to do it. Okay. And so then here, if t is 1, I'd have negative 4 over 1 times 12, which is 12. And then if t is 1, I'd have negative 4 over 12 squared, 144. Times 8, 8, 4. Okay, 4 goes into 144 36 times. Yep, and so 8 12ths, those both simplify. So 2/3, 0, negative 1/3. And then don't forget the negative here, so I'm just going to write a minus there. 4 goes into everything in the second part. 4 goes into 8 2 times, 1 time, 4 goes into 36 9 times. So I'd have 2/9, 2/9, 1/9. So now it's relatively easy to get a common denominator. 6/9 minus 2/9 is 4/9. 0 minus 2/9 is negative 2/9. Negative 3/9 minus 1/9 would be negative 4/9. And so then to find the magnitude of that, okay, just square everything. 16 over 81, 4 over 81, 16 over 81, 36 over 81. Ah, both of those are squares. Square root of 36 is 6, square root of 81 is 9. 6/9 is the same as 2/3. Well, we still have to find n. N is t prime divided by its magnitude, so divided by 2/3 is the same as being multiplied by 3/2. And then here's t prime. If we distribute, things simplify really nicely though. 2 goes into 4 2 times. 3 goes into 9 3 times. 2 goes into 2 1 time, but it's negative. 3 goes into 9 3 times. 2 goes into -4 -2 times. 3 goes into 9 3 times. So there's n. That's the hardest part, finding n. Before, what did we have for t? T was t, little t, over 8t squared plus 4 times 8t, 8, 4 over t. But say, again, say I had asked you to do this at t equals 1. Little t equals 1. So it'd be 1/12 times 8, 8, 4. Well, 4 goes into everything. 4 goes into 8 twice, and 12 3 times. 8 twice, 12 3 times. 4 once, 12 3 times. I strongly suggest that before you try to find B, what is supposed to be the relationship between all three of these vectors, T, N, and B? They're all supposed to be perpendicular to one another. So before you go on to find B, I would say make sure these two are perpendicular to each other. How do we do that? Dot product, right? So first times first, 4/9. Second times second, -2/9. Third times third, -2/9. So 4 minus 2 minus 2, that's 0. So these two are perpendicular to one another. So that makes me feel good, right? Now I want B to be perpendicular to both of them. Well, once you have two vectors, how do you find a vector that's perpendicular to both of them? So I have a vector, don't even think about these. I have a vector A, I have a vector B. I want you to give me a vector that is perpendicular to both A and B. How are you going to do that?
Some kind of trade formula.
I'll take cross product.
No, that's right.
Oh, really?
Yeah.
Feels wrong.
Yeah, that's what the cross product does. You take two vectors and their cross product is always perpendicular to each of those two vectors. Yep, so if I gave you 3, 5, 7 and 2, 4, 6, those were your two vectors. How do you find one that's perpendicular to both of them? Cross them. Okay. T cross N, yep. That's why N is the hardest one. T isn't too bad, right? Derivative, divide by length. N is the hard work. Then find B, it's just you cross your two answers already. So B is T cross N. So T is 2/3, 2/3, 1/3. N is 2/3, negative 1/3, negative 2/3. Okay.
So going down to 20?
Yeah. So I is negative 4/9 minus negative, so plus 1/9 minus J negative 4/9 minus 2/9 plus K negative 2/9 minus 4/9. So we get negative 3/9, negative negative, so 6/9, negative 2 minus 4, negative 6/9. Each of those simplifies. So negative 1/3, 2/3, negative 2/3. So that's our B. And we can check pretty quickly. Remember, this row is our T. This row is our N. I can make sure that B is perpendicular to both of them. So just check dot product. First times first, negative 2/9. Second times second, positive 4/9. Third times third, negative 2/9. Yep. So B is perpendicular to T. Check N. Negative 2/9, negative 2/9 plus 4/9. Yep. So it's perpendicular to both of them. So yeah, that's how you, if I asked you to find Tn and B, that's the process you follow. Time for like one, maybe two more. And then for those of you who walked in after I said it, you can omit this number 19. We didn't do reparametrizing with respect to arc length, so 19 should be omitted. What about 14? How would you do that? Yes, you would start by finding the derivative. So let me just see if it'll let me. No, I don't need to bold this. Huh?
Find the derivative and then use the parametric equation formula and plug in those points, right?
Okay, so there's our prime.
You plug in to see what T equals at the point 1.
Right. We have to figure out what's our parameter value. Yeah, because you would need the x to equal 1. Where does cosine equal 1? Well, 0, 2 pi, 4 pi. But then you'd also have to ask yourself, well, where does the y equal 2? Where does 2e to the 5t equal 2? Well, you'd need e to the 5t to equal 1, which is at t equals 0, right? So then you would plug in 0 here. So r prime of 0. Oops. That should be a bold r prime. I'm not going to fix it. So we'd have, what's the first component? 0. 10. Negative 10. Okay. Okay, so now what do we do?
So those R prime ones are going to be X naught, Y naught, and Z naught.
What's X naught?
You know, the R prime equations, you know, the sine of negative sine t. And
What is,
and then we just like plug it into the formula.
so you're saying X naught is 0?
No, the X naught is going to be the negative sine t. Then Y naught. And then the point's going to be, that's going to be your, that's, it's a different way then.
So when we're trying to find the equations for any line, not just a tangent line, any line, what do we need? We need a point and a direction.
Oh, so you're going to use
So what's our point?
1, 2, 3.
That's right. There's our point, 1, 2, 2. What's our direction?
Downward.
I mean, what's the vector?
It's not a point crossed with the arc right there.
You can't cross a point ever. So with vectors, direction is just like slope, right? What do we use to get slope?
Derivative.
So what's our direction?
Is just r prime 0.
Yeah. Yeah. Remember, the tangent line gives, the derivative gives like the tangent vector. So that's what gives us our direction. So that right there is the direction. Okay. So once we have the point and the direction, actually let me do this. I don't remember to type. So our x, so parametric equations, I need 3, right? I need one equation for x, one for y, one for z. So x, what am I going to start with? I'm only using the 2 things I've highlighted.
1 minus 0, is that?
1, right? Think back to college algebra. What's the equation of a line? It's exactly like that. Like the B, there was the y-intercept. Our B is just whatever value we go through. The M is like that part of the slope. And the X is the variable, for us is T, right? So it's X equals, there's like, we just do it in the opposite order, like B plus MX. So this is like our B plus 0 times T, right? So tell me what the equation for Y is. Y equals?
2 plus 10.
Yes. Right? So there's like our B plus the slope for the Y direction is 10, and our variable is T.
So z is going to be equal to 2 minus 10.
Yes. Yep.
So you got 10, 10, 10, 0, 10, 10. I see how you did the first derivative and then he plugged in 0. You get 0 and then 10.
What's
It's hard to get 10.
what's e to the 0?
1.
Okay. So 10 times 1.
Oh, you're doing this on back to the, okay, never mind.
Okay.
I went back to the original
Oh.
problem.
Okay. Yeah. No, you need to. Yep.
So the second derivative is all, the 0, when you do R0, it's always it's always coming from the first derivative.
Well, only if we're finding the direction for the tangent line. If I asked you to find the point on the curve, then you would plug it into the original.
Oh, okay.
You only use the derivative to get like slope. Huh?
Oh, we made that way too hard.
Okay.
Right.
Yeah.
You typed.
Yeah, I'm not going to change it. I'm going to leave the original up. I just typed it so I didn't have to switch back to.
Oh, you erased it, man.
But it'll be on the video.
No, I thought you wanted to.
Nope, I'm not going to leave it. What about 8? So I'm asking you to find the equation of a line. Again, so what do you need?
Direction.
Direction and a point. What's your point?
It's 906.
906.
And then calling. Oh, it's a little different.
Yeah, this one's different. So I want it to be. So I want it to be perpendicular to the plane.
Don't you just get y and z on one side divided by, like you just add 3y minus 4z to where it equals, so 3x equals 4 plus 3y minus 4z divided by 3, so x equals that equation. Then you can come back in and plug that in, or is that going to be way complicated?
Yeah, so think about what are the two things, like say I had asked you to find the equation of a plane. What are the two things you need to find the equation of a plane? Point and a normal vector. If you're looking at the equation of a plane, you could tell me probably lots of points. Like, Tim, when you just said solve for x, you could plug in like y and z equals whatever values you want, and then you could get the x that goes with it. Okay, so you could get lots of points on the plane. Looking at the equation, can you tell me a vector that's perpendicular to the plane?
Isn't this where we need a multiple of that plane? Or a multiple of the coefficients?
Okay, so
6x minus 6y.
I want a vector, not an equation. But use that idea and just make a vector instead of an equation.
So you give
It'd
me
be
some hint.
6i minus 6j plus 8k
Sure.
equals 4. Well, not 4, but you leave the 4 out.
Right. You could also just say 3i minus 3j plus 4k.
Okay.
Right? The coefficients of x, y, and z, those are the components of a vector that's perpendicular to the plane. Right? So a vector perpendicular to the plane is 3, negative 3, 4. We want our line, we already have a point. We want our line to be perpendicular to the plane, so we could use what as its direction?
Dot product.
What's the question again? Because I was missed.
Okay, So we already know our point, right? We need a point and we need a direction. Our line, what I want, okay, so this isn't going to show up on the video, but here's my plane, right? I want my line to be perpendicular to this plane, right? If I change the direction of the plane, then that changes the direction of my line. Looking at the equation of the plane, I get, here's my normal vector, right? I want my line to be perpendicular to the plane. What could I use as the direction for my line?
So can you cross product
The normal vector.
The normal vector, right?
It's running parallel.
Right. If my line is perpendicular to the plane, it's the same direction as the plane's normal vector. The normal vector is already perpendicular to the plane. So I want my line to have the same direction. So it is also perpendicular, right? I want it to be parallel to the normal vector. So the direction we'd use for the line would just be 3, -3, 4, or any multiple of that. You could use 6, -6, 8. That's fine as well. Any multiple of 3, -3, 4 is going to be perpendicular to the plane. So you don't need to do dot product. You don't need to use cross product. It's just right there. So your point is 9, 0, 6. Your direction is 3, -3, 4. And then you do the same pair. Well, there I say vector equation, but I'm more likely to ask for parametric equations because that's what we'll use later in the semester. But if I had asked you to do vector equations, you just do like, well, it capitalized automatically. R equals, so still think of y equals mx plus b, right? So our, like m is our direction vector. So you just have, 3, -3, 4. X, instead of X, we use T, plus B, the point it goes through. But you do have to, you can't add a vector and a point, so you just need to make that point like the terminal point of a vector, 9, 0, 6. Right. Yep. That's it. Yeah, you could leave your answer just like this.
This is perpendicular to the plane, which is parallel, like
Parallel to the normal vector. Yep.
And the normal vector is like 3, -3, whatever.
3, -3, 4.
And you just use it as those numbers as because it's a parallel, right?
Right. Right.
Let me see. And if it's a perpendicular, then and you use a different method, right?
Yeah.
Then you're using a derivative, first derivative, right?
This is perpendicular. Sorry, parallel.
I can't say parallel to the plane because there are infinitely many lines that are parallel to a plane, right? So there wouldn't be, I couldn't do that. There wouldn't be one line that's parallel to a plane. I could take this line, rotate it 360 degrees, it's still parallel to a plane. So saying parallel to a plane doesn't really, unless I'm talking about two different planes. Say I asked you to find an equation of a plane through this point parallel to that plane. Okay? So if I asked you to find the equation of a plane, we need a point and a vector that's perpendicular to the plane. What vector? So if I want a plane parallel to this one, what would I use as a vector as my normal vector? If I want my plane to be parallel to that one.
The normal vector would say the same.
Yes, if the planes are parallel, right?
Yeah.
They have the same normal vector, right? So you just use 3, -3, 4, right? If planes are parallel, their normal vectors are parallel. I gotta go in just a second. But, so now hopefully you'll know the answer to this one right away. How would you do number 6?
That product.
What does dot product give? When you dot two vectors, When you get a scalar, you don't get a vector. Cross. Okay, so when you first cross them, say, I'm just going to make something up. Say you get 5, 5, 5. Then is that your answer? Is that your final answer? Or if it's not, why wouldn't it be the final answer? What does the question ask for?
Well, you'd have to find the magnitude.
Right, so you just take the magnitude and multiply by 1 over, because then it's not likely that it's going to be a unit vector, right? So first, you just find a vector that's perpendicular to both of them, and then when you're done, make it a unit vector. How do you find the angle between two vectors? Yeah, and that formula is on the sheet, right? That's the first formula on the sheet, so I just use that dot product formula.
Find the angle between them, you have to like do stuff and side the curves and get an actual.
Well, so you'd use this. I don't think it's too weird. You do dot product, right? You just divide both sides by the magnitude of A and B, and then yeah, and then inverse cosine on your calculator. Yeah. One, which of those points is closest to the XY plane? Right, it's right on the XY plane, right? That one is the closest. What is the projection, so number 2, what is the projection of that 4, 4, negative 8 onto the YZ plane? So YZ plane, what part of the room is that? It's the back wall. So if we're in the back wall, what coordinate do you know?
0 is X.
X is 0, right? Whichever letter is missing from the name, that one's 0. The Y and Z would stay the same, so the projection would just be 0, 4, negative 8. If I asked you to project it onto the XZ plane, you make Y 0.
You're not going to ask us to draw any of those projections like you did in class.
I won't ask you to draw 3-dimensional projections, but I will ask you to do 2-dimensional. That's why I did it at the beginning of today's.
Oh yeah, those projections at 8.
Yeah.
Projection, shadow.
Mm-hmm. Yep.
You realize in Calc 1 and most of the guys in the class that we just can't draw at all.
That's why I said for 3 dimensions, I'll generate the graphs with Maple and give you the equations, and you have to do matching, right? Match the equation to the graph. Yeah. Here's the thing to remember about that. Some of them will be curves, and some of them will be surfaces. How many dimensions? So if I had something like, oops, let me switch back. And refocus. Refocus. So if I had something that went like this versus something that looked like this. How many dimensions is this? 1. All it has is a length, right? This is 1-dimensional, so it can only have one variable. It can only have t. So if it's a curve, you shouldn't look for things that have x and y and z in it. You should only have t. I mean, like, I could give you parametric equations, x equals, but it can only have t's on the right-hand side. This, I could have like z as a function of x and y. You can have all 3 variables in this. One of them is usually the dependent variable, but it might not look like it. I might not have it solved for 1, because remember, I could give you something like this, an ellipsoid, where it's like x squared over a squared plus y squared over b squared plus z squared over c squared equals 1, or, you know. So you see all three variables. So if it's a surface, you're going to see the x, y's, and z's. If it's a curve, it should only have a t in it. So at least, and they'll be all mixed together. So at least you can narrow it down that way. If it's a curve, you can only have one dependent variable. If it's a surface, you can have two. Because it's two-dimensional, I think you could, if it's a surface, you could flatten it out like a piece of paper and it would have a length and a width. But a curve, it's like a string, right? A string only has a length.
How many of those matching problems would there be?
Well, there will be one matching
How
problem,
many shapes?
but like 12,
What even
How many
there?
questions is the test?
13.
Well, we're matching.
No, one question is matching 12 things.
Jeez.
It's gonna be worth like 25
questions,
points.
but
No, it'll just be worth 12 points.
Just 12.
Just 12.
So if I'm gonna leave it at
1
the
point per, yeah.
If I'm gonna just leave it at the end, just because this is, you know, the.
Right, I mean, like something like that, there's no partial credit.
Right.
Right, so don't, like if you're trying to narrow it down between like 3, don't spend 15 minutes to get 3 points, right? And then like miss a problem that's worth 8 points, you know? So I mean, like, yeah, I would just say put a little star, come back, go do different problems, come back to it, and then like, okay, fine, A, B, C, you know.
do you have a trick to solving these problems? Like
Not really.
to identify,
So let me,
or we just have to practice it?
well, let's see.
That's good. Guess where I'm off to. Getting my city.
Yeah, to the state.
Yeah, I should have left like 15 minutes ago, but
Oh.
I'll be late. They won't care.
Okay, so like here's matching just with curves, right? So they just have 6. So one thing I notice is that 4 of them seem to involve circles, like in some fashion. 2 of them do not. When I see circles, that makes me think cosine and sine, right? So this graph right here and this one right here don't have circles. And when I look at the formulas, that's B and F. They don't have any circles. Okay, I don't know if this top one, it looks like maybe it goes through the origin, but this one definitely does not go through the origin. And so I might look and see, like, let's look at B. Could X ever equal 0? What would I plug in? Is there anything I could plug in for T to make X equal to 0?
0.
0. What would that make Y?
1.
And what would that make Z?
0.
0. 0, 1, 0. Which graph goes through 0, 1, 0? Where is 0, 1, 0? On the y-axis. Which of those graphs goes through the y-axis? Like,
The upper one?
No, because it doesn't. It misses. It
Looks
almost
like
goes to the origin.
number 4.
yeah, the 4. See, 0, 1, 0 is like right here, right? And then if you look at F, if I plug in 0 for X, Y is also 0, but Z is 1. So 0, 0, 1. Definitely this graph doesn't go through 0, 0, 1. But that one, I thought, oh yeah, that looks like 0, 0, 1 right there.
It's hard.
Yeah, it is a little bit harder to see.
Does it have this picture or the 3-dimensional?
What do you mean?
Is a picture you're going to draw to match, you're going to look something like this, or is it gonna look like this?
There's gonna be both.
Oh, it's both. So it's gonna be strings and it's gonna be
Yes, yes,
like.
mixed together, yep.
Okay.
So I just opened, they're from different sections. That's from 12.6, this is 13.1.
Oh, okay.
So then the 4 things with circles left.
So the 1, 2, and 3, I mean, 2, 3, and 5, that's related with cosine and cosine, right?
Yes,
Okay.
all 4 of the ones that are left, yep, still, you see that it is still, it's still making a circle. It's just kind of waving as it makes its circle.
Cosine and cosine.
Yep. So then I look at, like, when I look at 3 and 6, the Z never, it doesn't like go to infinity, right? The Z, there's a top Z and a bottom Z. For 2, it looks like Z is going to infinity.
Right.
And for 5, it looks like Z might be going to both positive and negative infinity. For 2, it doesn't look like Z ever gets negative, right? It looks like Z is always only positive. So I want to think about one where the Z has to be positive and it could go to infinity. And then, so when I look at A, see the X has cosine 2t and the Y has sine 2t. That's going to make a circle. The Z is e to the negative t. Could that ever have a negative value? No. E to any power is always positive, right? So it can only have positive Z values. And could I make Z go to infinity? By making t a negative number. Yeah. So this A has to go with graph 2. And see, then when t is negative, I would have e to a positive number, which means the numbers in front of cosine and sine are getting bigger and bigger, which means we're making bigger and bigger circles, right? So when Z goes to infinity, the circles also get bigger and bigger. When I look at C, look, the X and Y are cosine and sine, so the X and Y are making a circle, and Z is sine of 5t. So Z, what's the biggest Z could ever be? What's the largest value Z could ever be? No.
5.
No.
You mean up? I mean, what do you mean largest? Like, it can go, where it can go the largest?
Look at the equation.
Z equal to sine.
Yeah, Z is sine of 5t. So what's the biggest that will ever equal?
So like T could be anything. Like
T can be anything. But what's the biggest Z would be?
Sine anything would be. Sine.
1.
1. Sine never gets bigger than 1. What's the smallest it could be? Negative 1. So the Z has to be between 1 and negative 1.
Really? Is that why sine can never be more than 1?
The sine was really.
You're on the unit circle,
Okay.
right? So you can't go outside the unit circle, right? So you could never go above 1. That's the highest point on the unit circle is where Y equals 1.
Because I always thought, okay, maybe because I'm taking the degree, because the experiment is 60 degrees, then it can be also 1. But, oh, that's right. It's always goes to 1.
Yeah.
You know, you come back to.
Yeah, right.
Thinking,
Yeah.
okay, never mind.
So your Z, your X and Y make a circle, and your Z can only go from negative 1 to 1. So which graph do you think that is? We already know we're done with those 3. We're down to 3, 5, and 6.
Seems like the 5 is, well, I think the 6 one goes to the, see there's a limit on it.
Yeah, it's 6.
Right.
It's 6.
Because
Your
5
X,
still can go.
your X and Y are making a circle this way, right?
Right.
But your Z is going between 1 and -1 as you go around the circle. Yep. Okay. So let's look at D. I'll move this up a little bit.
But so is 3. 3 has like a limit.
Mm.
Yeah, 3 is pretty much.
But X and Y aren't making a circle. You're not making a circle as you go around X and Y. Which 2 letters are making the circle in graph 3?
The X and Y.
C and Y.
So Z2. I don't know if it's hitting Y.
So is the circle going, do you go up and down?
Yeah.
Okay, so then it involves Z.
Yeah.
Does it go back to front?
Back in front, yeah.
Does it go left and right?
No.
No. So since it goes back to front, right, it starts in the back and it comes forward, right?
Yeah.
So it's going back, front, up, and down. So X and Z make the circle.
Yeah.
And so look at equation D. So X is cosine, Z is sine, Y is t, which means Y can get as big as you want. Just
Yeah.
plug in. So X and Z are making the circle as Y gets big. So you go farther and farther to the right while you're making your circles that go up and down, back and front.
Yeah. But you're right. That would be the spring thing.
Yeah, that's this one. Yep.
That's a quarter.
Because your circles are going back to front and Y, yep, you go all the way to the left or to the right. Yep.
What's the last one? The 2, right? The 2 is the last one.
We have 5 left. 2, we did 2.
Yeah.
We did 2 already.
2 was the very first set of equations.
Oh, okay.
The one we have left is 5, where X and Y are still making circles, right?
Yeah.
But the Z can be both positive and negative. And when you look at equation E, you see the X and Y are making circles. They're cosine and sine.
Right.
But Z is natural log. And when you think about the natural log graph, oops. The natural log graph looks like that, right? So it does go positive, and then when it goes negative, it goes down negative fast,
Okay.
right? And when you look at this graph, it doesn't go positive very fast. See how those circles up at the top are really close together?
Yeah.
But here, where it starts to come down, it goes down really fast.
So
That's
that's
how I
something to
learned.
think about. So
Yeah.
natural log goes up slowly.
Yeah.
It comes down really fast.
Yeah,
I see.
yep. Okay, so those are like, that's usually what I do is I look for circles.
Yeah.
But then when it doesn't have circles, then I see what happens when I plug in t equals 0. Okay? That's always a good thing to do, plug in 0.
Are they going to be similar or very close to those?
I'm not making any promises about that.
What did
You
you
mean,
ask?
you mean
Are they going to be similar to these?
the pictures in all the.
Past assignments. So then the ones with the, stop.
The one with the little
With the surfaces, so the 12-6. You don't have to know the names. I'm not going to ask you the names of anything, okay?
That was hard one, like when they're, on
Yeah.
the
The
side.
homework, yeah, the
web.
web assignment was hard.
Yeah, I'm not going to make you know the names. But like, okay, so when I look at this equation,
Okay.
what's missing?
That's,
Z is missing. So first, think about, with X and Y, what would that make? Well, the X and Y are both squared.
yeah, so that's a circle.
Right, except for that, so if it had the same numbers in front, it would be a circle.
Oh.
Since the X has a 3 and a Y doesn't, it's going to be an ellipse. okay? So the X and Y are gonna make an ellipse, and since the Z is not there, that means Z can be anything, so we'll have our ellipse, and it can go up and down forever, right?
When Z is not there, it can go up and down.
Forever. Right, there's no restriction on Z. Since Z is not part of the equation, Z can be anything. So that's up and down forever. So that's got to be this one right here, because that's an ellipse that goes up and down forever. Now this one, what's missing? Y is missing. This one doesn't look like our regular, like any of those formulas, but I would think about, okay, what if I were going to graph this in 2 dimensions? I would probably solve for Z. So I'd get Z equals 5 over X. So if we have Z equals 5 over X, and think about graphing that, you can plug in points. It would look something like this, right? You can't plug in X equals 0, because that would get 0 in the denominator. It would go to infinity. When X gets really, really big, that fraction gets really close to 0, right? So when X goes to infinity, you go to the right, it goes closer and closer to 0. If X is negative and you make it big numbers, go to the left, it gets close to 0, right? So your graph should look something like that for X and Z. Now, since the Y is gone, I would get that shape in the XZ plane, but Y goes left and right. So I'd get this shape forever to the left, forever to the right. So let's look and see. I know it's not either of the first 2. It's definitely not this one. What they're doing in this graph right here, they rotated it so that the X is going left and right and the Y is going, but see how they rotated? The Y equals positive 5 is in the back and Y equals negative 5 is in the front. I won't do this to you. I will always, positive X is forward, positive Y is to the right. I will never change, on this test, I won't change it. On later tests, I will have to change it to give you a better view, but I'll always tell you, like, this isn't standard view. For this test, X always comes forward, Y always goes right. But what they're doing with the graph that we had is they're cheating and they're kind of connecting those two, even though it's undefined there. So they're having that one side goes down and then all of a sudden they're really going across an asymptote and connecting them. I also wouldn't do that. You would see 2 separate pieces on the graph. I wouldn't connect them. Right? Okay, so this one, X, Y, and Z are all there, right? But look at so here's one way, one kind of little trick. Cover up one of the variables. So if I cover up this, X equals Y squared, what's the shape of that graph? It's a parabola, right? So with the XY plane, so that's in the floor, right? It should be a parabola. Let's cover up the Y. So if I cover up the Y with the XZ, what is that going to make? Another parabola, right? So when you look in the XY plane, which is the floor, it should make a parabola. When you look in the XZ plane, which is the sidewall, it should make a parabola. Okay? So, and again, it's not the first one, right? Because there I just see circles and lines, right? This one right here, notice they're having X go to the right again. I wouldn't do that to you. I would have X come forward. So in the XY plane, which is the floor, we do see that parabola.
Right. And parabola also.
No, I see an ellipse.
Yes, ellipse. Yeah.
Okay.
Right? What is... I'm trying to think. I'm trying to think about the XZ plane. Oh, the X, they're showing a different trace than I did. So maybe you saw this, Andre. So the floor, it's a parabola. XZ, that's the sidewall, right? So that's like you're going over the top. How do I want to, I'm going to do a snip of this and paste it. So I can show you here what I'm talking about. So the one that they already have drawn, that's in the floor. So you see the parabola in the floor. The XZ plane would be right here. We'd start at the top, we'd go through the origin, and then come down in the bottom, right? So you do get a parabola both ways, okay? This one. Okay.
So it's got X, Y, and Z.
Okay, so here's another trick. And notice they have 0 on the other side. So then you think about, should it go through the origin? If you plug the origin into the equation, does it work? What's the origin? Tell me, what is the origin? 0, 0, 0. If you plug 0, 0, 0 into the equation, does it work?
Yeah, because I read something where you have squares.
It's gonna be 0.
Well, if it's equal to 0, right? I mean, if it was equal to 1, then no, it wouldn't,
Yeah, so,
right?
So it's,
But yeah, if I plug in x equals 0, y equals 0, z equals 0, it's equal to 0. So does the first,
cross the,
it should go through the origin. Does the first graph go through the origin?
No.
Nope. Does the second graph go
No.
through the origin? Nope.
No.
Does the third graph go through the origin? Yeah, the third one is the only one that goes through the origin, so it's the third one. Yep. So would this one go through the origin?
Yes, I mean the first one.
No, the equation.
Oh,
The graph that we're trying to
okay.
select, should it go through the origin? Yes or no?
I'll say yes.
Okay. What do you say, Andre?
If I plug them in 0, I will not get the
Right.
0.
You'd get 0 equals 400.
Right.
So it can't go through the origin.
So it's gonna be something.
So it can't be
both.
it can't be either of those.
So
So it's either got to be
So either that one, not.
right. It's only this one.
It's only two. 'Cause
Yeah.
that's what it's supposed to do.
Right. That one goes through the origin.
Right.
So there's this one.
It's the ellipsoid.
That goes to, okay.
It doesn't go through the origin.
It doesn't?
No.
Because it's
The origin is in the middle of it. It goes around the
Oh,
origin.
the thing around it and then there's, okay.
Yeah.
Oh, I see. I always thought everything went through the
Yeah,
origin.
Should that one go through the origin? No.
It's two there.
Right, because you'd get 0 equals 2, and that's not true.
So,
So it can't be the second one.
yeah, so the first one looks like it could not.
It might, right, it might be the first one.
Or there's another one, so who knows?
What do you think about these other two?
Okay, that one doesn't.
It can't be the third one.
Third, yeah. So either this one or that one.
Yeah. So let's
See,
then
the fourth one is harder too.
then think about intercepts. Okay. What about x-intercepts for this equation? Don't look at a graph, look at the equation. What do you do to find x-intercepts? Right, set the other letters equal to 0. So you would just get, these would be gone. So you'd get negative x squared equals 2. Does that have a solution? No. X squared is going to be positive. Then when you multiply by a negative, you can't get a negative number equals positive 2. So there are no x-intercepts. It can never touch the x-axis. What about y-intercepts? Yeah, what would they be? So then you just like cover up the x and the z. And so you would get that, the y has a positive in front of it, right? So you get 2y squared equals 2.
To get p equals to, what you want equals to?
It wouldn't be equal to 0.
You mean
Y squared.
you want x to be what? If you cover
Oh, if you're finding y-intercepts, you make x and z both 0. So they're just gone. So the only thing left is y. No?
1.
Right.
If
Or,
you put 1, then it's gonna be 2 times 1 is 2.
okay,
Yeah.
what else
A
could you plug in?
negative one?
A negative one, right?
Yeah, 1.
Because y squared equals 1 gives y equals plus or minus 1.
Right.
Right.
What about the first graph? Does it, and look at, again,
I
they,
see and the y is negative 1 and 1.
yeah. And if we look at that graph at the bottom, it doesn't,
Doesn't have anything.
yeah, right.
So it's only that.
Right, so it's the first graph.
So you pretty much narrow it down,
Mm-hmm,
between whatever you left, and then from
Right.
there, then you can go.
right. So what about number 8? Should the graph go through the origin?
Yeah.
Yeah, because you'd get 0 equals 0.
Right.
So it can't be the first
So
graph,
second,
possibly the
possibly.
second.
what else? And third.
Yeah,
And-
all of them,
all three.
possibly all of them.
All three.
Yeah.
So here, notice that the z is not squared,
Right.
but the x and y are.
So that's-
So you could like get the z by itself. No, ellipses, they're all squared.
Oh, it's all three.
So I would get the z by itself and subtract 4x squared and 5y squared, and then do the same thing. Like if I cover up the y, so then I'd get z equals negative 4x squared. What does that look like? Right, z equals negative 4x squared.
So x squared, which is parabola, right?
Since it's negative 4x squared, it would open down. So a parabola that opens down. And if I cover up the x, well then I'd get z equals negative 5y squared, which would also be a parabola that opens down. So in the back wall and the side wall, it should be parabolas that open down. And do you see this graph? Here's the side wall, parabola that opens down.
Right.
Back wall, parabola that opens down, right? Which is not the case here, right? You don't get anything, you don't ever get parabolas
Right.
out of this.
Okay.
And there you would get, actually you'd get hyperbolas, right?
Oh,
Yeah. Okay, should this one go through the origin?
No.
No, right? So could it be the first graph? The first graph went through the origin. Is it supposed to go through the origin? No, so it can't be the first graph. What about the second graph?
Possible.
Possible, it doesn't go through the
And
origin.
there's a square, all three are squares, so is it?
Yeah, exactly. So if they're all square and it's all positive, it's an ellipsoid. Yep. So this is like a good guess, right?
Yes.
This one, I would give you a different view. What's happening with that one is it's two different pieces that don't go through the origin. So I would make sure that you would see that it doesn't go through the origin, which means that would be a possibility. This one does go through the origin, so it would have to be either this one or that one. But you could, if you didn't know that was an ellipsoid, you could find x and y intercepts, right? So what would the x-intercepts be?
1.
And
Negative
1 and negative 1. What would the y-intercepts be? No. Z-intercepts would be the same, but the y-intercepts would be different.
So y equals
You know, I mean, y square be equals to
to
the,
negative 1.
No.
you mean, you're talking about the equals to the number?
Yeah, because you're plugging in, to find y-intercepts, you're plugging 0 in for x and z. So all you'd have left on the left-hand side is the y.
7,
And,
negative 7?
yeah, plus or minus 7, right?
Right.
And so again, WebAssign has the axes rotated, which I won't do. But yeah, so you see the x's don't go very far out,
Right.
but the y's do, right?
Yeah.
So that makes sense. Plus and minus 1, plus and minus 7.
7,
Yeah. Okay.
makes sense.
All right. All right. I gotta go.
Yeah.
What, you gonna go?